Let's take a look at E. In E, we've got negative 2/3 x is less than or equal to 12. Let's deal with this problem one step at a time. Let's get rid of the fraction first by multiplying both sides by 3. The question is, does the inequality flip? And the answer, as of right now, no. We multiplied both sides by a positive 3. So, the inequality should stay the same. On the right-hand side, I multiplied by 3. Well, 12 times 3 gets me 36. On the other side, I multiplied by 3 to get rid of the denominator, which still leaves me with a negative 2x. Here's where I run into the problem now. How do I get the x by itself? Well, here's where I need to divide both sides by a negative 2. Here's where I make my switch or flip here. So this is going to flip because I'm dividing both sides by a negative. So now I'll switch to being a greater than or equal to. So now x is greater than or equal to. Well, 36 divided by negative 2 is negative 18. And that's my final answer. That gets rid of my 2's and my negatives, leaves my x by itself. And so let's see if we graph that. So here's negative 18. It's greater than, so pointing to the right. The equal to means it should be a bracket this time. So let's draw out the interval notation for that. It starts on the left with a bracket at negative 18, comma. It continues on forever where we've got an arrow, so towards infinity. Remember, infinities always use parentheses, so that's my final answer. Bracket at negative 18, comma, infinity with a parentheses. Let's take a look at F. In F, we've got 4x plus 1 is less than negative 31. So to solve this one, we'd start off the same way. We would get the 4x by itself by subtracting 1 on both sides, which would get me a 4x is less than negative 32. Notice nothing switched. I might have done a negative to both sides, but it wasn't multiplying or dividing. So it doesn't change. Only if you're multiplying or dividing by a negative. So, last step here would be to get the x by itself, would be to divide both sides by a 4. Does the inequality flip? Well, the answer is no, because we didn't divide both sides by a negative. We divided both sides by a positive 4. So it'll stay as a less than. And then on the other side, we have, let's see, a negative 32 divided by 4 is going to give us a negative, a negative 8. So we've got a negative 8 here. It's a less than, so it's pointing to the left. It's a less than, not a less than or equal to, which is important too, which means I'm going to have a parentheses, not a bracket. So, reading my graph from left to right, I'm starting out with an arrow, which means I'm starting off at negative infinity. And continuing to my negative 8, where I have a parentheses. Remember, the negative infinity will always have a parentheses no matter what. That's my interval notation. Negative infinity to negative 8, both with parentheses. Continuing along, we've already done E and F. Let's take a look at G. In G, we've got 1.25x is greater than or equal to 2.5. Now, we did problems like this in the last section when we did equations. The idea is I'd like to get rid of all the decimals. Now, notice, though, on the left-hand side, I have 2 decimal places to get rid of, but on the right-hand side, I only have 1. So, I'd like to get rid of 2, though, not 1. 1 wouldn't be enough, so I need to get rid of 2. Because remember, whatever I do to one side, I have to do to the other. So, I have to do the most I need to do to both sides. Well, to move 2 decimal places, I need to multiply by not 10, but 100. So I'll multiply the left by 100, but then I have to multiply the right by 100. That moves everything 2 places. So what that means is for the 1.25, it turns into 1, 2 places moved, turns into 125x. Now, the greater than or equal to will stay a greater than or equal to because I multiplied both sides by a positive, not a negative, so it will stay. Now, multiplying the 2.5 times 100 will again move it 1, 2 places. What's going to go in that little second place here that we had nothing in it? It'll go in as a 0 as a placeholder, so I'll get a 250 on the other side. Okay. Now, how do I solve this equation? Well, I need to get rid of the 125 by dividing both sides by a 125. And that gets me that x is now greater than or equal to, well, let's see, we've got 250 divided by 125, which is just the number 2. So here's the number 2 on our number line. My answer was greater than or equal to, so that means it's going to point to the right here. The equal to means I'm going to have a bracket instead of a parentheses. So if I read my graph from left to right, I'm starting with a bracket at 2. And then continuing where I've got an arrow to infinity, which should always have a parentheses. That's my interval notation. Second to last one here, we've got negative 6x minus 8 is greater than 6. Well, the first thing that we'd want to do is, again, get x by itself, so we'll add 8 to both sides. That will get me, let's see, negative 6x is greater than. 6 plus 8 will get me, let's see, 6 plus 8 will give me 14. So that gets me 14. And last thing we do is to get that x finally by itself, we'll divide both sides by a negative 6. Be careful. This one does matter. We divided both sides by a negative. So that's going to flip the direction of our inequality. That's now going to become a less than. Remember, we did this, though, to get rid of the 6's and the negatives, so I'll still have my x on the left. On the right now, let's see, what do I have? I have 14 over negative 6. So I have a negative. The problem with 14 over 6 is that it can be reduced a little further because 14 and 6 are both divisible by 2. So let's reduce it. So if you reduce both by 2, that will give you a negative 7 over 3. Okay, so that's going to be our answer. We need to still graph it. So here's negative 7/3 somewhere in our graph. Let's see, we had a less than symbol, which means it should be pointing to the left. The fact that it's a less than, not a less than or equal to, should mean I'm having parentheses, not a bracket. So, reading our graph from left, which starts with negative infinity, to it stops at negative 7/3, where we have a parentheses. Negative infinity always has a parentheses as well, so that's our interval notation. Negative infinity with a parentheses, comma, negative 7/3 with another parentheses.